Right, hey you Thames. Hello, how are you guys getting on? Just want to send my regards and hope everyone's doing okay today. I know that it's awfully stressful with having to do all the work at home and everything. I know that it's rather difficult. Do the best you can, look after yourselves and stay safe. Today's lesson, we're going to be focusing on, we've done formulae, we're going to be working on calculations, we've done formulae, we've done percentage yield, and now we're doing the idea of writing equations. And I know this is a really, really challenging part of the GCSE course, and in fact, it's just a challenging part of chemistry as a whole. I want to reassure you that this is a very limited section in terms of your exams that you'll get, but I understand that today will be challenging. I'll do my best to try and add in as many levels into this as possible. So, okay, I'm just going to get straight into it. So I'm going to share my screen with you guys. Share screen. There we go. I'm going to go Oh no. Let's go for that one. Oh no, don't want that. Want that one. There you go. My mic should be back on. Can you hear me now, Shan? Oh, that's a nightmare. Yeah, my mic should be back. There we go. My mic's back on. Yeah, I can hear you. Cool. Sorry, Shan. Sorry about that. Yeah. So what I ought to try and do, my laptop is having a little bit of a leave studio. Don't quite know what that's going to be. Okay, my laptop's having a bit of a hissy fit in terms of being able to, it's kind of struggling with what I'm asking it to do, and the screen's got a fault. Do you know what? I will continue on. I will slave on. Okay. So now that we've done that, what we now need to do is we now need to realize that what we're going to be doing is putting this into the context of an equation. And that is a lot more challenging. So let's just start introducing, so writing equations. Writing equations. So we're going to be going from word to symbol. That's my task. Now there are several levels of this. And so the first one is they're going to give you the entire thing just in words. So let's do question number 1. So let's do the reaction. Write equation for. Write equation for A, iron reacting with oxygen to produce iron 3 oxide. They give you everything in the equation. Right. Have a go at that now, please, year 10s. So the first thing I want you to have a go at is have a go at being able to do that. So pause the video and then have an attempt at it. I've realized what's happening here is that I have my laptop is don't know quite how to. Does that make any difference? I don't know. Anyway, so have a try at that. All you're doing is converting the words straight into symbols. So obviously you've had a go at doing it. Now, since you paused the video, let's now have a go at this. So everything is in the question. They're telling you the reactants, and then they're telling you the products. So all we need to do is translate that out into an equation. So the recognition that iron, of course, is just simply going to be Fe. It's nice to include state symbols as well. Plus O2 going to, and this is the tricky bit, into Fe2O3, iron 3 oxide. This is why you have to be able to do the translation from words to symbol before you can tackle the equations part of things. Okay, so let's now balance it. We've now got, of course, the second step is to balance it. I'm going to need 3 of those, 2 of those, and 4 of those. That's the final product. It's nice to say state symbols again. Iron oxide, of course, being ionic means it's going to be a solid. Okay, let's have a go at the next one. It's slowly going to increase in level. So then we're going to get something like something that's going to be less let's say less obvious to you guys. So let's say we're going to take hydrogen. Hydrogen reacts with oxygen. Now, what they've done in this scenario, so write down my equation, please, folks. Again, pause the video, have a go. So the difference in level with this one is the fact that they're not giving you the product. They're expecting you to be able to figure out what that product is. That's what they're expecting. So in this case, not difficult to translate out the words to symbol. So we're going to go to H2, which is hydrogen, of course, plus O2, and this time the product's missing. And what you need to realize here is that they're not trying to make this super challenging. They're trying to reinforce this idea that students need to be able to understand that you get common products in chemistry. Common products, these stable products, are ones that you're always going to be seeing over and over again. And in this case, we're going to form water. The most common mistake there is that people produce H2O2. They think they're just joined together. This is not a common product. That's called hydrogen peroxide, very rare. Has to be made in a very complicated process because it doesn't want to be made. It wants to make those stable things. Stable things include water and CO2. And now we need to balance it. 2 there and a 2 there. So this question was harder than the previous one because they're expecting you to be able to give the product without them having to tell you. Okay, so question number C. Let's do making it harder again. Let's now do ioxide. You need a Roman numeral. Iron 3 oxide and aluminium. Aluminium to produce aluminium oxide. Aluminium oxide and iron. Okay, pause the video, have a go. Now this one is the first one. This is the first one that introduces us to one of our rules. So this is the first one that does this. I'll see if I can, okay. So it's bringing in a rule. Now this question is easier because once again, they've given you all the products. I've only got 4 people watching, so I've got, I think I have, well, I'd like to see more of our class making an appearance, but we'll work on that as time goes by. If you turn up now, folks, please just make sure that you give your name on the chat so I can see you as a register. So they've given you everything you need here, folks, in order to create the equation. They've given you the reactants and they've given you the products. So they've lowered the level. So now we've just got to translate it out to be Fe2O3, so iron 3 oxide, brown, plus aluminium. Aluminium, of course, is just Al, unlike anything that ends in -ene or -gen, which is in a pair. And now here's your rule. This is explained, of course, in reactivity. The aluminium is more reactive than iron. So we're going to get a displacement. This is going to be a displacement reaction. And we're going to form aluminium oxide, Al2O3, and iron. And then they want you to balance it, a 2 here and a 2 here. So relatively straightforward because what they've done is they've given you the products, given you reactions, given you products. You just have to translate it out into symbol. And then, of course, balance. I think lots of students do forget the balancing bit. Okay. Okay, so now we're going to make that a next level harder. By the way, the rule, and we're going to start collecting these rules. So definitely worthwhile collecting these. So rules for equations. Rules for equations. Rules for equations. Number 1. Word to symbol and balance. That's your key steps. These are your steps. Words to symbol and then balance. And now we start picking up our rules, which is number 1. This is a rule that just supports those students who always find it difficult when the very common question is, I don't know what I'm producing. And so the rule here is swap the metal. Now, this is a great rule. But it's really this is a last ditch rule. This is if everything else fails. But lots of students like to start here. And so it seems reasonable for me to do so. So in case of this one, that one followed the rule, swap the metals. This one didn't. Neither of these two did, because there was no exchange of metals occurring. It was simply these were both oxidation reactions. The B, by the way, was a combustion. I'm going to do another one. I think most people will probably be able to recognize this one. This reaction, of course, needs to be known because it's called the thermite. This is the thermite reaction. So D, let's do something a bit more challenging that people won't recognize. So this was, let's do silver nitrate. Silver nitrate reacts with sodium chloride. Sodium chloride, give equation. Okay. Just leave it there for a moment. You guys can now pause the video. Don can come along if he likes. I don't mind. So pause the video, have a go. Right, translate words to symbol. First thing, silver nitrate reacts with. So these are my reactants. These are my reactants, and they've given me no products. Higher level question, translate from words to symbol, silver nitrate. Tricky one, just because you have to remember that Ag is a +1 and NO3 minus. Got to know them, folks. You can't, the table won't give you those. Got to know them. I'm going to react that with sodium chloride. Now, the reason why I give you this particular equation, it's very common at GCSE, because it follows my first rule. You can't do this in terms of reactivity. It doesn't really work out properly when you run it in terms of reactivity. But this is a precipitation reaction. It's one of our chemical tests. So what's going to happen here is that we'll just simply swap the metal. If you look at an equation and are really lost with it, a great rule of thumb is to switch the metals. We're going to form AgCl. I'm going to swap the metals. Swap them over. I'm going to get AgCl and sodium nitrate. You've got to check your formulae. That one is correct because it's Ag1 plus and Cl minus. That is correct. Sodium nitrate, Na plus, NO3 minus, all okay. Right, balance it, already balanced, which is quite nice. Check it if you got it right. And all I'm doing there is following my rule, swap the metals. Great rule, works well. I'd love to get a little bit of feedback, folks, on the chat. If you're struggling with equations, you can always ask me to give you another example equation for you guys to have a go at. So please do talk to me on the chat. What's the buzzing sound? Sorry, that's my laptop speaker. I'm trying to keep my laptop cool, Shan, because it's busy freaking out on me, and it's I'm not entirely sure how to stop it, which is just a nightmare. I know, I apologize for the buzzing sound. I can't really get, I can turn it off, but if I turn it off, I'm pretty sure my laptop's going to have a meltdown. We will see. I'll see how it gets on. It's annoyingly, I think my laptop has a hardware issue. I'm going to have to buy myself a new laptop because I think this one's got a major problem. I need to replace it. It's a nightmare. Broken laptop. Right. Okay. So question E. So again, swapping the metals is super useful. Right. The next one, the next set of rules. The next set of rules. Swap the metal. Right. Next set of rules are said to be acid-base rules. Acid-base rules. So I'm going to have to keep my little fan on, I'm afraid, guys. My laptop is busy crashing on screen. It's a nightmare. I don't really know how to stop it. So, acid-base rules. Here are the 3 ones that you need. So, number 1, and I'm going to put them in 3 different colors to try and help kind of give a translation for this. So, we've got acid. Sorry, I don't like putting that first. Metal. Metal plus acid goes to salt and hydrogen. Hydrogen. Salt and hydrogen. Right, so next version of this is, I'm going to change my color to then dark green. Metal oxide plus acid. It's going to go to salt and water. Now, I notice now that I'm going to stick with green, and there's a reason for this. Metal hydroxide plus acid. Notice I'm still in green, salt and water. And the reason why I've done that is because I realize that the equation is going to be the same. It gives me the same products, which is a really useful trick to know. I'm going to do my last color in red. Metal carbonate. Metal carbonate plus acid goes to salt, water, and CO2 and carbon dioxide. So those there, you need to put these acid rules. You've just got to, unfortunately, learn. Now, students often say to me at this point, they often say, what's the salt? How does that work? And so the salt comes from the acid. I'm going to have to try doing something with my laptop this evening to see if I can repair it, because it's seriously up with this thing now. I feel like it's because it's running this in the background. That's what I feel like I'm really struggling with. And I feel like I need to try, if I could. Don't know. I can't seem to make that work, I'm afraid. My laptop is having a full meltdown at this point. I don't think the problem is it's not even hot either. There's something proper wrong with it, and I don't really know how to fix that. Anyway, I will keep going. Is the screen doing the flickery thing? Yes, it is, Rue. It's an absolute nightmare. It's not just doing the flickery thing, Rue. It's gone completely stir-fry crazy. So let's now apply these rules. There is another set of rules we need to put in place before we do that. The next set of rules are what the salt is. So how do we know what the salt is? So you can do salt rules, salt rules. And yes, I know it seems like an awful lot of rules, folks. If we use hydrochloric acid, I am going to make a chloride salt. And I now need to give you an example of this. So if I used sodium metal plus hydrochloric acid, I'm going to make sodium chloride and hydrogen. The hydrochloric acid decides the salt. So what would happen then if I used nitric acid? I used nitric acid. Right, I'm going to create a nitrate salt. Let's do an example. Let's keep with the same example. Sodium metal, metal plus acid goes to salt, sodium nitrate, and hydrogen, salt and hydrogen. And then the acid decides the salt. You'll notice, by the way, in a lot of ways, this is actually following. It's okay. Kieran asked, don't you only need to learn the first equation? No, you can't. It's not going to be enough. Right. Once we've done that one, let's do sulfuric acid. Sulfuric acid is going to create a sulfate salt. Let's use an equation. Let's try and keep some continuity between the others. Metal plus acid, sodium plus sulfuric, and yes, you need to learn your acid formulae. Yeah, it's going to form sodium sulfate. And you notice I'm having to create formulae for the salt all the time. Plus hydrogen. So the sulfuric acid decides the salt. So those rules are so important. It's very easy for students to become very lax about those, and you do have to be aware of them. So what we now need to do is we need to put these equations into action. So let's now use them. So metal plus acid, salt and hydrogen. Yeah, metal oxide plus acid, salt and water. Metal hydroxide plus acid, salt and water. Metal carbonate plus acid, salt and water, and CO2. So let's now put those into practice. So let's now do, let's do the first one. Choose a metal. Let's go for calcium. Calcium reacts with hydrochloric acid. Right, guys, have a go at creating my equation, please. Calcium reacts with hydrochloric acid. Pause the video, have a go. Wait, can you go back to the salt rules, please? Of course I can. There you go. Salt rules. There's my, oh, sorry. There's my salt rules. What's really interesting for me with my laptop view is the fact that when I stop writing on it, the screen starts to settle back down again. I don't quite understand why me playing with the screen is causing it to shake like that. Shan, you can always pause it. Okay, thanks. Shan, you can always pause it when I'm doing those bits and then click continue. Yeah. So calcium is actually hydrochloric acid. So they're telling me the reactants, but not telling me the products. So the first thing I'm going to do is I'm going to analyze which equation this is. That's a metal. I'm going to try and do this in a different color if I can. So this is a metal, and I'm reacting it with an acid. So the rule I'm going to apply is metal plus acid, salt, and hydrogen, which is MASH. So I'm going to have calcium plus HCl. Everyone knows HCl, of course. It's one of those acids they never forget. And now the question is, what's the salt? I'm going to, for most common mistake is everyone's going to do that. That, of course, is I've got to be really careful with pushing something inside. I don't know, Rue. Oh, maybe. Don't know. I don't know whether it's got worse. I've just pushed on it and I think I've made it worse. Don't know. Anyway, so I'm going to form that one and hydrogen gas, and then I've got to remember to balance it. Yeah, maybe it is a problem with it just being something pushed against. Oh, well, you see, I stopped writing on it. It starts to correct itself. I don't exactly know how to play with this now. I'm just going to give up. Okay, so now that I've got that, well, do you know what? Maybe I'll try writing on my tablet super softly. Nope, makes no difference. Let's go to question F. So question F. So again, focusing on those equations I've just given you. Let's do sodium. Let's do sodium oxide. Now you realize the level of difficulty that this is coming across. I don't know. I don't know why I've suddenly got text appearing on my screen. It's really weird. Sodium oxide. Let's choose an acid plus nitric acid. So once again, I'm not giving you the products. I'm just giving you the reactants. You need to translate out the words into symbol and then deduce what the product is going to be. And the products are going to come from my rules. So I've got sodium oxide. Well, sodium Na plus, O2 minus. Cross them down gives me Na2O. Right, I'm going to react that with nitric acid, HNO3. Right, I'm going to form a salt and water in this case. Not salt and hydrogen, because now it's an oxide, I get water instead. I'm going to form sodium nitrate and H2O. Balance it. 2 sodiums, only 1 sodium. I've had to check my formula on that, by the way, folks, because it's Na plus, NO3 minus. Cross them down, it's a 1-to-1. So what I now need to do is I now just need to balance it. So I'm going to need a 2 in front of the sodium. Therefore, a 2 in front of there, and now it balances. Much harder. I'm going to try and make my screen a bit brighter. I can't actually see my screen very well. Brightness, I think, is in here. There we go. Makes everything so much worse for my poor screen. My screen is just so damaged. Don't know why. Next, EFG. Okay, so now we need to apply another one of my rules. So what we're going to do is we're going to focus on now, instead of the oxide, let's do the hydroxide. Now, this is the most common equation you're going to see at GCSE. Sodium hydroxide plus hydrochloric acid. Right, same thing again as the oxide rule. You realize that all of this all depends on us being able to make sure that we know our rules. So in this case, it's NaOH plus HCl. See, what I know is happening here is my camera is still running. That's why it's really struggling with my... If I reduce that down, maybe that'll... Front-facing IR, green screen, general. I just want to turn it off. It's really such a nightmare. But if I stop that, then I stop the camera. Stop cam. Ooh. Can you still hear me, folks? I wonder if you can still hear me. Let's go back to there. This might actually help my thing settle down a little bit. It's gone completely stir-fry crazy. Still hear me? Cool. Okay. I think I've managed to turn off my camera. So what that might mean is that might actually level out a bit and stop it shaking a bit for me. It's really thinking about it. Okay, so this one is a metal hydroxide and acid. Just salt and water, NaCl, sodium chloride. The metal goes with the chloride, and we're going to get water as our byproduct. Most common equation at GCSE, that one. Going to make this a little bit harder, EFGH. Let's do sodium hydroxide and sulfuric acid. Everyone have a go at that one. Now, this one, I've translated the words out to the symbols for you. Have a go at that one. Pause the video. Have a go at doing it. Check your answer with me. So in this case, I'm going to form sodium sulfate, Na2SO4, because Na plus, and I've got to remember, you cannot go very far with chemistry without learning your complex ions. And I'm going to then, of course, produce water as well. Now I've got to balance it. 1 sodium, 2 sodiums, put 2. Next. Sulfate, so 2 oxygen, sulfate ions, they're 1 and 1, that's okay. Hydrogens, oh, I've got too many hydrogens. If I balance that there, I'm done. Much harder. Now, I don't want you guys to worry. If you're really struggling with this process, don't worry. I'll post some questions on the classroom for you to have a go from word to symbol. But I just don't need to worry about it too much. because in reality, what's going to happen here is they're only going to have probably one of these questions in your real exam. And so I just want you to be, you know, having a go at them and trying to make that improvement, but it is tough, this. Let's do one more. It'll bring us nearly to the end of our lesson. So we now need HI. So we now need to do a carbonate. Let's do the most common carbonate. Calcium carbonate. Calcium carbonate reacting with, let's do nitric acid, much harder. Reacting with nitric acid. Again, pause the video. Kieran asks, will the metal just displace the hydrogen in the acid? Yes, Kieran, that is absolutely correct. It does. Now, the reason why it's doing that is because the hydrogen, of course, is behaving like the metal, because hydrogen, of course, becomes H+. So it's just going through a standard kind of swap as if hydrogen were a metal. So yes, absolutely, that is correct. So calcium carbonate reaction with nitric acid. So we need to build this calcium 2+, carbonate, CO3 2-, crossing down. They cancel out, Ca, CO3, reacting with nitric acid. Nitric acid is HNO3. The reason for that is because this is Kieran helping out, H+ plus NO3-, which gives us HNO3. Right, I'm going to form, the salt is going to be the nitrate. So it's going to be calcium nitrate. Now, calcium, of course, is a +2 ion. Nitrate is NO3-, crossing down. I'm going to need two nitrates. So Ca, open brackets, NO3, twice, really hard. It's a carbonate. The rules that we've been learning, Mr. Duncan, can I post the link to this on our Google so people are not watching it are aware? Sure, go for it. Absolutely, I really appreciate that. Thank you. And I'm going to get CO2 and I'm going to get water. Balance the equation and I'm done. Amazing with that answer. So I'm going to, because my laptop is having a minor heart attack here. What I'm going to do is this has definitely been enough for today. Here's what I need you to take away from this lesson. I need you to be taking away these sets of rules. They are so important. All of those are some of the most fundamental and basic chemistry bits that will support you. And I'm going to post on the classroom. I'm going to post a whole load of word to symbol questions that you guys can use these rules. Please just apply them. Try applying them first with the rules in front of you, then applying them without them in front of you. And I'll post 2 sets of questions so that you guys have got plenty of practice. I'm going to end today's lesson there. Let's see if I can bring you guys back. Here we go, and see if I can go for this video again. Amazing. Let's bring the cam back online. Wow, that's amazing. I've got it on I've got it on infrared, which I really shouldn't do. Front-facing camera. There we go. Right, guys. I think that should now be working. Let's go for that guy. Right, guys, I'm going to leave you there today. I hope you found it useful. Do please keep practicing your rules. Your rules are where everything's at. And as I said, I will post onto the classroom straight away. As soon as this is done, I'll post onto the classroom with your practice questions and the answers. Please do them, mark them yourself in order to make those improvements. I will see you all soon. See you next lesson. Ciao, folks. See you later.